Hello and welcome to Electronics 10. No, didn't go too well there. Okay, so in the last episode I spoke about the need for an electron source and electron destination. And we needed a continuous length of wire. Otherwise, if there was a break in the wire, there would be no electron flow. So we needed the wire to be continuous, and we needed a source and a destination. So here I want to expand on this a little bit more. Um, so yeah, so we need to make sure. So I'm going to draw another picture here, and so yeah, we need to have, and I want to explain what's going on with this picture. So let's do that. So again, we're going to do what we did before. We're going to have the electron source, and we're going to do this break again, and then we're going to do a point here, and we're going to go like this, like this. And I guess, yeah, I mean, I'm thinking perhaps I should, I could prepare some of these pictures earlier on. We'll see. I don't think they're going to be too complicated though for a while, so it may not be that useful. And I kind of don't mind drawing these pictures as long as the information is clear. Of course, I make an exception in terms of graphs, and but yeah, I mean, realistically, I probably will want to do that. Okay, so just gonna just finish off this this picture here. Put the destination there. We're going to write that there's no flow here. And this is going to be like a break, so it's like for air or something like that. So, so this is interesting, isn't it? Because this actually to show where the electron flow is occurring. So if we make physical contact with the wire leading to the source, contact with the wire leading to the well, we'll say from the source to the destination. So any kind of wire, so you can see that it doesn't matter, even though there's that break there, as long as there's a contact somewhere else, it doesn't matter. That's the whole point. We once again have a continuous path for electrons to flow. Okay. So these dots here, the dots indicate metal to metal contact, metal to metal. So yeah, just to be explicit regarding that. Yeah, between the wire pieces. So yeah, so even if it was cut, you can always just do that, and then you're going to recreate it. And that, of course, is going to start leading us into circuits. Okay, let's just okay. So let's just go. No, it's not that way. Okay, let's just start a new section. So now we have continuity. From the source to the destination. So it goes right there. When it's got the gap, it goes down, and it goes down to the right, and then up, and then to the right. As just saw. I could scroll back up, but you know, it's you just go earlier in the video, I guess. So this is analogous to using a T-fitting, which is a common plumbing fitting to divert water. Common plumbing fitting used to divert water. Obviously it's called a T because it's a T shape. Yeah, I think that's the most, I believe it's the most common fitting used in plumbing. A common plumbing fitting that diverts water. Okay. Yeah, and I could actually put through a different segment of pipe. Different segment. It's a good word, segment. Okay. So yeah. Okay. So I will actually go back up. Actually, now I think about it, because I wanted to put this area with no flow. So we've got this has got no electrons. Because no continuous path from source to destination. Okay. What else can we say? Okay, so the difference between water. So the difference between water pipes and copper wires. And I may actually, I mean, this isn't strictly true, and I may actually speak about it in Electronics 12. But I'm just going to say this here now. But yeah, this is one of those things which is a more complex topic. But sometimes it's nice to know the more complex topics, even if you only just to get a flavour of them. So and between water pipes and say metal wires, why not? Is that no wear occurs. In a wire, whilst corrosion occurs. In pipes. So yeah, so water is obviously does a lot of damage. You know, it does damage to everything, really, even rocks on the sea and on the seafront and stuff like that in pipes. So weathering, yeah, weathering. It's a bit of a geography thing there. Okay, but actually, I'll just start a new bit. So electrons do encounter some friction now. Do encounter friction as they move. So like anything, well, except for, of course, if you shoot something off in space. Electrons do encounter friction as they move. And this friction can generate heat in a conductor. Okay, so that's important to note that. Yeah. Okay, so I could just all right, so let me just so yes, that's all that's all going to be in that sort of topic, because obviously this thing with friction is going to be very, very core. So I've just got a few sort of additional comments. Are kind of mainly just talking about what I've already spoken about, but they're good nonetheless. Okay, so let's just put this down. So in conductive materials, the outer electrons, remember they're on the left-hand side of the periodic table, in each atom of free electrons. Can easily move around. So these are just sort of like self-contained sentences sort of thing. Also, all metals, I'm not sure I actually explicitly said this, are electrically conductive. And this dynamic electricity, as opposed to static electricity, dynamic electricity, electric current, also known as electric current, is the uniform motion of electrons. Through a conductor. Okay. Anything else? Yeah. So, and that's opposed to static electricity. Which is unmoving. Yeah, and I did say it's unmoving, but of course, if it's on a conductor, then there's probably be a huge discharge. So yeah, is it unmoving on an insulator? Brackets. Accumulated charge. Accumulated charge. Formed, and this is going way back now. It's formed by either, they were good, those first ones, or deficiency of electrons. Okay. Of electrons in an object. Okay. Yeah, and we did the glass, and it's formed. And this is a bit more of a formal way of putting it. By charge separation. It's an interesting term here. Charge separation by contact and the separation of dissimilar materials. Okay. All right, good. So, and then as we just spoke about, we'll just finish off with that. So yeah, we'll just put this here. For electrons to move continuously, indefinitely, forever, through a conductor. Well, I suppose that resource is finite. Must be a complete unbroken path. So yeah, that's what we need, a complete unbroken path. And this is going to, for them to move into, just like the marbles, and out the conductor. So yeah, so that's going to cover it, and it's going to, going to be time for circuits now. So yeah, thanks for watching.